Welcome to the world of multidimensional thinking, a cornerstone of modern analytics. In today's data-driven world, it's crucial to move beyond basic reporting and dive deep into your data to answer complex business questions. This is where multidimensional thinking comes in. We'll explore how analytic databases and multidimensional queries transform raw data into actionable insights. Most of us are familiar with relational databases. They're great for general-purpose reading and writing, with strong guarantees like durability and consistency. But when we need fast, large-scale analysis, like identifying patterns across time and location, we turn to analytic databases. Analytic databases are designed specifically for fast reads of historical data, enabling us to answer complex, multidimensional business questions with ease. What exactly are multidimensional queries? Think of a question like, what is the sum of salaries for our top talent employees in each gender and site? This question has three key components. Filter defines the specific data you're interested in, like high performers. Grouping specifies how you want to categorize your data, such as by city and ethnicity. Measure is determined by how you're aggregating, such as a count, sum, or average. Answering multidimensional questions boils down to these three steps. As another example, how many people older than 50 who didn't receive a raise last year resigned? It's this filter group measure framework that forms the foundation of analytic thinking. Cubes, also known as analytic objects, are at the heart of multidimensional thinking. They represent business concepts in a multidimensional model. Imagine them as structured containers holding your data. A cube is made up of records in a table, with each record consisting of a list of values. These values are called properties. There are two types of properties. Data properties are values directly from the data source, such as birth date and salary. Calculated properties are values derived from data properties, such as age and double salary. As the name suggests, multidimensional emphasizes the role of dimensions in cubes. This is where analytic databases truly excel. Dimensions and hierarchies enable you to filter and group your data in dynamic and powerful ways. Dimensions group cube records into meaningful sets called members. Hierarchies add structure to your dimensions. They define relationships between members. Let's go over an example. A location hierarchy might have levels like country, state, and city. Each of these levels have predefined set of members, and the dimension maps cube records to these members. There are different types of dimensions. Data property as a level-based dimension, for example, grouping employees by gender or location. Recursive or parent-child dimensions, which have a dynamic number of levels, where each member can only have one parent at any given time, but can vary over time. Like an organizational structure. Banding dimensions, for example, grouping salaries into ranges like 0 to 40, 40 to 50, etc. Concept as a dimension, classifying employees as high performer, average performer, or low performer based on their performance score. There are many types of dimensions, each uniquely designed to serve a specific purpose. The final part of our multidimensional query is our measures. Measures are functions that operate on a set of records to produce a single value. Think of them as calculations. For example, total direct compensation of employees, the median performance rating, the count of employees promoted in the last year. Now that we are familiar with cubes and their characteristics, let's see a few multidimensional queries in action. Consider the query, what is the sum of salaries for our non-top talent employees? The cube is employees, the filter is top talent equals no, and the measure is sum of salary. We first gather records represented by top talent equals no. Then we evaluate measure on these records, summing the salaries. We did it! We answered our multidimensional question. Now let's add some complexity. What is the sum of salaries for our non-top talent employees by gender and location? The cube is employees, the filter is top talent equals no, and the measure is sum of salaries. The grouping is gender and location. First create cells for the grouping dimensions, then filter records and map them to cells according to the grouping dimensions. Finally, evaluate measures on each cell. That's it. We answered our multidimensional question with grouping. Another type of analytic queries are drill-through queries. They allow you to go deeper into your data. They return detailed lists of records that meet your query criteria. This is useful for exploring individual records behind the aggregated results. They can provide both data properties and calculated properties. Let's do a drill through over our previous example with drill fields employee ID and salary on male cells. Our result would be employee 2 with $20 salary and employee 4 with $80 salary. To wrap up, most business questions can be framed this way by answering 4 questions. 1. What object am I asking about? Employees, promotion events, paydays? 2. Which population do I care about? Young people, females, double promotions, bonus payouts? 3. Which groups do I want to look at? Canadians, Americans, people with raises in the past year? 4. What do I want to know about these objects? Average direct compensation, median performance rating? That's a wrap. Today, we've just begun to uncover the vast potential of the Visier analytics platform. With multidimensional thinking, you can transform raw data into actionable insights by harnessing the power of calculated properties, dimensions, measures, and hierarchies. These tools don't just reveal the stories hidden in your data, they empower you to make smarter, more confident decisions. Next, let's look at how to write our queries using Visier formula language, an intuitive way to create custom metrics on Visier platform.